Okay, shall we go on? Cool. So let's start with the first chapter. So the first chapter is just going through the basics that you do need to know from machine learning here. What is the idea? Let me just motivate you a bit, like every course, that you need, it's good to study deep learning. So probably, I mean, a few years ago I had to give these slides. Nowadays I don't need it anymore, but still, it just wastes a bit of time. Yeah, I mean, there are lots of things with deep learning that are doing very fine nowadays. I mean, the most interesting one as of today is ChatGPT, right? Or any all of those LLMs, which are pretty much starting to behave like human beings in terms of logics and discussions. So human-like conversation is nowadays the most important one, but there are actually crazy other stuffs which we had seen at that particular point of time was crazy. For instance, image segmentation, image recognition, or for example, the AlphaZero idea, the algorithm which can beat the champion, like the world champion, chess champion in the matter of just 24 hours training. Also, lots of other things nowadays. You have like generating models which can do crazy stuff. They can generate new images. They can mix different images. They can give you context for different things. And these are all basically being done after deep learning was there. So the ideas behind all of those stuff had been in the literature for a long time, but it was always treated as a kind of science fiction. Like theoretically, you think, yeah, that could be happening, but we cannot do it. Why? Because there's nothing to be able to do that in practice. And deep learning was the guy who did it. So where the story of deep learning started, it basically started here at UofT in 2012 with AlexNet. Doesn't mean that we didn't have deep learning before. I mean, we had deep learning since 1950s. You're going to see in the lecture a bit of history about that. But basically, the time where we started to feel confident that really deep neural networks are going to do something was when the AlexNet came out. So there was the challenge, the ImageNet challenge, and this ImageNet challenge was being tackled by different approaches. And some people still believe that machine learning or AI is capable of doing very good. But up to 2012, no one was really using machine learning for that challenge of image classification. And in 2012, AlexNet could just win that challenge. And from then on, it was always deep neural networks that won that challenge. And this somehow people started to just revisit the idea of deep learning. So the idea is that using AlexNet, as I said, you were going to see it in the lecture, but it was quite older than that. So the whole algorithm, everything was somehow implemented in 1998 by LeCun. But up to that point, nobody believed on that. This was the point where it started to do. Then after that, it was quite fast. Like people, in the matter of 2 years, they had the GoogleNet and VGG, those known models, and then just 1 year after ResNet, residual networks came out, which could simply beat the human accuracy. Like you give an image and you ask a human being to just classify it, what is inside the image, and the number of mistakes a human could do is now more than the machine. It was in 2015. So people started to write in magazines that AI is starting to beat human accuracy. And this was just the beginning of the story, right? So after that story, ChatGPT came out. People started to just make human dialogue with that. So you just ask ChatGPT to do this homework for me, and then it's going to give you the answer, right? And then it's going to give the answer even better than what you can do, right? So that was crazy. So you ask who Bloom is, and this one, by the way, is like 2 years ago when I was revising the slides. I put this one. I guess if you ask today, you're gonna get much more sophisticated answer from ChatGPT, but it's gonna answer you very well. No grammatical mistake, no typo. It can even reason for you, like because of this and that, you put them together. This is the reason. And that was crazy, right? Many people started to be afraid of human destiny, right? What can happen to us because this AI is just eating us? And chess playing was another thing. So the idea of chess playing again with a computer was quite old. So Alan Turing, the very well-known computer scientist, he actually started to design a program on a computer that can play chess. And people like Shannon started to study whether this is feasible or not. Many people said this is computationally impossible because eventually when you want to just do it with computer, then you need to do a kind of exponentially large search, which is, I mean, even if your computer is extremely fast, you would never ever be able to do it in a feasible amount of time. It's going to take like forever. But people started to just use deep learning. And what is this specific thing about deep learning? We're going to understand they can approximate what we want to do with very small amount of data without going through that, crazy search, for example. And they started with deep thou. They just played against Kasparov. Kasparov defeated thou. They came back a couple of years, 7 years later, with Deep Blue. Again, Kasparov defeated, but the next year, Deep Blue could just defeat Kasparov. And this was the first time a computer is really defeating someone in the level of Kasparov. And then from 1997 to 2005, there was a battle between the two. But in 2005, human being just gave it to the computer, so that the AI could beat every single world-class champion in chess. No one is able to do it anymore. I mean, there have been some people a few years after to just draw with the AI, but that was the last things, right? So this was the story. 2005, people started to believe on it, but still, it was not the true deep learning that we do. So you need to have this huge computer with crazy algorithm and a significant amount of time to get ready for playing against a champion. But it was 2017 when this team DeepMind came out with the idea of AlphaZero. So it was AlphaGo, and then AlphaGo Zero, and then AlphaZero. And in AlphaZero, this was an algorithm which was able to do any board game. Mainly, they just developed specified an algorithm to play chess. And it didn't need really to go through a huge data or wait for forever or access to a crazy CPU and GPU. It was able, with a fair, I mean, it was still good, but a fair amount of GPU and CPU, it was able to get trained in 24 hours, just 1 year before the match starts, and then it was able to beat the world level champion. So this one now was crazy because you can build one machine, it takes just 1 day, and that is even better than the world class champion, right? So there are also new versions. I mean, AlphaZero has become a concept, but there are also new versions which are trying to even push it further, but like all of them are working with deep learning, right? So natural language machine translation is another thing. Again, I'm not sure. I mean, I could not believe that this is going to get a time that I say that, but I'm not sure if you remember Google Translate before 2010. So, like, another problem that we had with computers was that we were imagining that whether we can design a machine which is able to translate any language to another. Yeah. And this was some sort of very hard problem. I mean, you might say, no, this is not, but this is a kind of, at some point, people consider it AI complete problem. So if we can do it, we can do a lot of other problems. And this started from, say, 50s, where people start to just look at the, you translate words and then you start to learn the combination and the syntax of the sentence. And then it got into statistical machine translation. That one became dominant in 2000s. but still was not working. So if you could remember before 2010, how was Google Translate working? You just ask something in one language and it gives you literally word by word translation. So if you do know both languages, you see that the translation doesn't really make sense. If the sentence is more longer than something, you still it off. But then it was around 2015 where the idea of neural machine translation started to come up. Like use deep learning to do that. And we're going to do this particular example in this course. We're going to design that machine. And you're going to see that, given the knowledge we have, this is not a very hard thing to implement. And people started to do it in 15, and then at some point it was crazy. Like it was translating really good. And then many startups started, like Google Translate, I mean, just shifted to that one, put everything to work by neural networks, but also, what is it? Deep, yeah, I forgot the name. DeepL company just came out and it was just doing crazy, right? So you just give the text and then complete text, and then it's going to give you, it sees the German text and it gives you the perfect English translation without any typo, without any mistake. And that was the point where deep learning just, hit every other approach for translation. And nowadays, basically, whatever you have as a machine translator is working by neural networks. It's just deep learning. So that was this regarding this problem, and I hope this somehow motivates you that deep learning is something specific as compared to many other things that we did now before deep learning. And then you might ask me this particular question: what does exactly deep learning mean? And I don't expect you to understand it today exactly, but you're going to understand it in 1 or 2 weeks. So what deep learning is and what is there different from the general idea of machine learning. But if I wanted to give you a basic definition, deep learning refers to the subset of machine learning. So machine learning is the whole universe where you teach a machine to do something, and then deep learning is a very tiny subset of it, but very dominated, very powerful. And then this subset is using deep neural networks. So when you talk about deep learning, you are always talking about neural networks and the deep version of them. And this guy is using these deep neural networks to execute learning tasks. Now, I don't expect you to get this definition right away because there are lots of things here meaningless for someone who has no background in that. So first of all, what does machine learning mean? What it means, machine learning. What do you mean when you are talking about machine learning? This is the first thing that we need to know. The other thing is that what is the neural network and what makes a neural network be, right? And you might think this is a very sophisticated definition, but no, it's not. It's a very simple definition, okay? So neural networks, what is it? We're gonna understand it, and then we're gonna understand when do we call a neural network deep. And then the last thing is that what do you mean by a learning task, right? What is a learning task? Well, you might have a bit of feeling about this, like you teach some, like a kid, you teach to do something, you want to do it to a machine. Yes, that's pretty much this, but we're gonna have a very concrete definition of learning task as well. So these are the things that we want to just clarify so that you have the understanding about the machine learning basics, and then we can go on with deep learning.